if she gets kicked off, the cable guy, that was kind of creeping me out the other day, he said, AT&T guy just shows up and said, I got to check something over here. Then he starts working on the other side of the house. I'm like, dude, you said it was over here. Anyways, he wasn't up to no good. But what ended up happening was, since I told him we have AT&T, Uverse, whatever, Wi-Fi. And shit. Oh, I know why it's not on right now. It's because it's the middle of the night in China. But 4:30 starts up again. Curling. I can watch that shit for hours and hours and hours.
I was totally gonna guess curling too for some reason.
I mean, every 4 years I gotta kind of figure out all what are the rules of scoring it, but there's so much strategy involved in that. It looks like so much fun. Okay. All right. So hopefully you guys got all warmed up and did a bunch of integrals from that one section where we had the substitution stuff take place. So today we'll talk about a couple things, and probably going to be ending early today. One, because I don't want to do too many topics, but two, I have to get someone over to the East Bluff side of the Back Bay for their orthodontist appointment. And she has to be done and to get her back before tennis practice starts. So her appointment's at 12. Had to pick her up at high school. Told her to ride her bike, but that's not realistic. She'd miss tennis practice. Anyways, so we'll probably be done here sometime around, if I give myself 11:40, that should be enough time. Okay, so 7.1, integration by parts. Okay, so now this is really not so much a technique. I don't know, they call, this entire chapter techniques of integration. And, we'll study one, but this is more of a formula than anything else. Okay, so let's just make an observation here. So now I'm going to be using Leibniz notation, and this is the actual stuff that Leibniz was trying to cook up. Okay. If I was to integrate the derivative of u times v in Leibniz notation, that would equal the integral of u dv plus v du, which I can separate into two integrals, u dv plus v integral du. But on the other hand, this is just equal to uv, right? Okay. And so where we conclude here is that uv is equal to the integral of u dv plus the integral of v du. So if we solve for the integral of u dv, we get uv minus the integral of v du. Okay, so now for those of you that haven't looked at anything in 7 weeks, all of this might be frightening the shit out of you. Okay. I can, go through it with, f of x and g prime of x and blah, blah, blah. But what we want to do here is when we're given this integral right here, you want to identify a u, and we want to identify a dv. Okay. Now in the formula, we need what v is. Okay. So that means we're going to have to then produce du. That's easy enough. Okay. Hopefully you guys now understand what I was saying back in 180 for you guys that were with me in 180. The taking derivatives are easy. Monkey can do that, but going backwards and finding and recovering from the derivative what the function was, not always the easiest thing. That's why we develop these techniques. Okay. All right. So the idea here is to apply this formula, and hopefully the resulting integral that's left over, that minus v du thing, the hope is that integral is easier to do than the one you started with. Okay, so let's go through the standard example here. This is something that we have not yet looked at. And the reason is because we need this technique in order to pull this off. Okay, so what do I need to identify? I need to identify u, and I need to identify dv. Now the entire integrand has to be represented there. Okay, so one choice I could make would be this. The dx is always going to go with the dv. Okay, now you find du, and that's just going to be dx, and v is now just going to be e to the x. Okay, now we'll save the plus c till the very end of the problem. Let me write that down. Save plus c till the end. Okay, so our integral of x e to the x dx equals uv minus the integral of v du. So that's equal to u v minus the integral of v du. And we see that that is an integral that's much easier to do. Okay. So what we end up with is x e to the x minus e to the x, and then plus the constant c. Okay, now I've been telling you guys that the plus c is actually an important part of the whole thing. Don't want you to forget it. But when I say save it to the end, I need, at least I think, to justify why we can save it till the end. Okay, so let's say I didn't save it to the end. Let's say this was e to the x plus a constant k. So then this would be uv x times e to the x plus k minus the integral of v du. Well, that's going to be e to the x plus k dx. Okay, so what I get is x e to the x plus x times an arbitrary constant minus this integral, which is e to the x plus kx plus another arbitrary constant. Now, hopefully, it is apparent why we don't have to put it there. Okay. Now, I have, over the years, been asked to come and evaluate, various adjuncts. Not so much anymore, but when I was younger, like right after I'd, gotten hired, they'd ask me, hey, can you kind of come in and because I got an interview at Fullerton and give me some pointers. And I remember this one dude, he was doing a Calc 2 thing. That's the cool thing about OCC. Our adjuncts get to teach pretty much most of our classes. Whereas you go to Saddleback, it's the same two people teaching Calc 3 every year. Whereas with us, you do at least get some variety. And anyway, but I pointed this out to him. He said, you don't have to put the plus C till the very end. And on hiring committees that I've been on, where we ask people to prepare a little lecture and then we give them on the spot problems, nobody ever talks about this, at least that I'm aware of. But I think this is an important thing that we should all recognize. Okay, now, an alternative approach to this is we could have made different choices and said, all right, let's say that u is e to the x, and then dv is equal to x dx. Du still going to be e to the x dx. Now the v is going to be x squared over 2. So the integral of x e to the x dx is equal to uv minus the integral of v du. Okay. Now, this is not wrong. but not helpful. All right. The whole idea with this integration by parts business is we want to make sure that the integral that we're left with is at least similar, if not easier, than the one that we started with. Okay. And I think that if I was to go into my daughter's 9th grade math class that she has today and say to the people, hey, what looks more complicated, this or this? None of them have any idea what any of these symbols mean. Maybe the X, but and they'd all vote for this one, the second one, this guy right here, just because there's more shit going on, right? Okay. So here's an example of something that's not on our list of basic antiderivatives, the natural log of X. We know what the derivative of it is, but we don't know until today what its antiderivative is. Okay, so let's see. We don't really have much of a U substitution choice to think about here. So this looks like we're going to need to do parts. But if we're doing parts, there really isn't a whole lot we can play around with here. The dv has to have dx in it, okay? Now the natural log part has to go either here or here. But if we put it there, then we'd have to integrate it, and that's like begging the question, right? Okay, so just the dx goes there, and I'll throw a 1 in and not erase it just because. Okay, so now we go through and we figure out that du is 1 over x dx. And make sure you don't make this mistake. I had a group of people over the summer. It was about 10 of them in my Math 180 class. I had a rough summer. I did 180, 185, and 280. And in the 185 class, it's a group of 10 of them. They must have all had the same, they must be all in the same study group or whatever, but they were saying the derivative of that was that. Like, no. Okay, anyways, v would then just be x, right? So I go through and do this, my integral, and I usually just start referring to these things as I. This is equal to uv x e to the x minus the integral of v du, which is x times 1 over x dx. So we get x log x minus the integral of dx. So the answer is x ln x minus x plus constant c.
Can you explain how you identify the u and the derivative of v?
Well, in this one, there really isn't much of a choice because there's only natural log and dx. So I could have let u equal 1 and dv be the rest of it, well, then du would be 0 dx, and v would be, well, we don't know, because that's what we were trying to find in the first place. So the important thing to remember about integration by parts is that the entire integrand has to be represented. Okay, you can't, and it's not composition, it's not something in a denominator. Integration by parts works on products. Okay, so let's try something here and see what we can come up with. For example, what would you do with this guy?
Use substitution.
So if you just want to do a straight substitution, you could let u equal the log of x, but then du is 1 over x, and you got this dangling x hanging out here. So x would be e to the u. You know, we're going to have to use parts.
You just use dv as ln x, since we know now.
Yeah, and these are the kinds of things that I want you to be doing. So let's try this. Let's let u be the natural log of x, and let's let dv be x dx. Okay, now the reason for this choice, and I'll do the other choice next, is because 1 over x dx and v is x squared over 2. And so I know that the thing that I'm going to have to eventually integrate is just going to be some power of x. Okay, now that comes from years and years of experience doing this stuff. But it's not going to take you guys years and years and years. It's not, okay? Nor it didn't take me years and years. It might take, you know, a couple dozen problems or something like that. And this is on you, you know, you have to do this stuff. You can watch me do problems, and you can get real good at watching me do them, you know? And then we're in person, you know, and you're watching them. I can even make you feel like you're helping me. And I go, hey, what do you think about this? And you go, yeah, I was just about to say that. Oh, yeah, and then what about this? And you go, oh, you're reading my mind. But then you get home by yourself and like, okay, where's Bob? All right, so you got to get in there. Your job is to work on problems that are hard, get stuck, and then come to me and I'll get you unstuck. Okay. So the integral is uv x squared. My wife feels like that she needs to shout everything that she says. Minus the integral of v du x over 2 dx. So the integral that we're left with is easier than the one we started with, so we'll just go ahead and finish it off. So we get 1/2 x squared log of x minus x squared over 4 plus a constant c. Okay, now let's try u equals x and dv equaling the natural log of x dx. So du is just going to be dx and v. So now we need to remember what it was. It's x ln x minus x, right? Right there. So our integral is uv x squared natural log of x minus x squared minus the integral of x natural log of x minus x dx. Yikes. Okay. Now, in a perfect world, you would have seen this problem in the exercises, maybe remembered, and for the one of you that suggested, well, why don't we say dv equal to this, since we already know what its antiderivative is. If you were working all by yourself and doing problems, whatever, I bet you would have tried that and then got to this point and gone, ugh, okay. And then maybe abandoned ship and tried it this way and got there. That's what I'm after with all you guys. It's this independence, this willing to fail, willing to get in there and, fail 2 or 3 times before you get something, All right.
Professor, I think you might be muted or something.
Yeah, I can't hear anything. And then it's still, nothing's been written on the screen for a little bit. at least on my perspective.
Yeah, same with me. But even when he was writing on the screen, it was also muted.
And I thought I was having bad internet today, but it's not just me. He usually gives off his number to one classmate, but I don't think he has done it for any of us.
I don't think we have any.
don't think
His
he
phone
gave-
number though.
I think it's on the last notes
What's in
from
it?
the last class. Let me
I
see
think
if
I-
I can find.
I think I
was on
have
the
the screenshot
syllabus,
of it.
wasn't it?
I think I have the screenshot of it. If you want, I just sent out the number though, but I'm not calling him. Oh, Jonathan and now is the host though.
Yeah, he
Sure,
was.
he'll just
Uh,
log out and log back
yeah.
in.
Yeah. His internet must have went out.
Yep, I got lag earlier as well. There he is.
How long was I out for?
minutes.
A little bit. The last thing that was written on the screen was I equals x cubed e to the x minus the integral 3x squared e to the x dx, and then it just froze.
All right, so that was only a couple seconds because I only did the next step after that one. Wonder why my Wi-Fi didn't go bad. That was a Zoom issue.
Yeah, sometimes it does that if you're running too many programs at once.
Now maybe I should close shit out on my iPad probably, huh? All right, well, let's get back to this here. Start. I remember 2 years ago we were all talking about this and we realized none of us knew how to start the Zoom thing. Tyler Booger had to have a special Zoom call with all of us. Okay, so anyways. So there's nothing that says you can't do parts again. And quite often you do have to do parts several times. Okay, so this is us doing parts again. Give you guys a second to write that down. All right. So this is x cubed e to the x minus 3x squared e to the x plus 6. Now, let's not do integration by parts again. X e to the x. We do this integral so much. You just start to have it memorized. X cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus a constant c. Okay, so I remember being at Cal Poly Pomona after taking this class, you know, where we learned integration by parts and all that stuff. But some of my friends, you know, were a little bit behind me, like they had to start in pre-calculus or something. But eventually, when they would get to Math 115 at Cal Poly, this is where you learn how to do all this stuff. They'd be complaining about their asshole professor, who on a test put something like this, like x to the 8th e to the 5x. Okay, now, can you do this problem? I'm asking. Like, let's
In
say
theory, yeah.
I put $500 on the table. First person to get the correct answer gets all 5 of those $100 bills. Now you're motivated, right? Okay, but this problem, is it hard?
Doesn't look hard, just looks tedious.
What it is annoying. Okay, now there's a difference between hard and annoying. All right, as a matter of fact, for any of you that are physics majors, and I was a double, you know, physics and math, and actually more of a physics than a math person. When you get to something like this in a physics problem, you're kind of, whew, thank God, because at least that's an integral that you can do. As I was saying at the beginning of class, sometimes, man, like you can't, like, you know, you just write something down like e to the x over the natural log of x, or the integral of log x times e to the x, or something like that. These things are all circular. They, you know, doesn't work out. Try to find the area. This is like typical Isaac Newton problem. You know, what's the area underneath this curve? Not x squared, you know, from A to B. So you start having to approximate shit. All right. Now, what I think you should do is, you know, search out problems like this, you know, try to learn how to manage a mess. I mean, this to me right here, this is out of hand as far as the test question goes. You know, there's too many dumb places where you could, you know, make a mistake and still, you know, you're going to get marked wrong, but you got marked wrong because you lost a minus sign or something. One characterization I think about me is like, I try not to test you guys on mess management. You know, like if I wrote some random 3x3 matrix down in a math 285 test and I said, find the inverse of it, there might be a bunch of gnarly ass fractions involved that are ugly looking and stuff. And then you're going to have to manage the mess. That's not what I was after. I wanted to know if you knew the concept of determinant. I want to know if you know the concept of integrating. So a problem like, you know, this one right here, that would be about the worst of it. And since I probably wouldn't want to see all those dumb fractions, I would probably start the problem off like this with a 4 in front, just so we would get rid of all those fractions. Okay, well, sometimes you get things that are a little bit unusual. So for this one here, we'll just start trying some stuff. So if u is that, then dv would be sine x dx. Du is going to be e to the x dx, and v will be negative cosine x. Okay. And so when we run it through the formula, the integral is equal to uv negative e to the x cosine x minus the integral of v du. And I absorb the minus sign over there. Okay, well, we look at the resulting integral and it didn't get better. But then again, things didn't get worse either, right? So maybe we can try it again here. We'll do parts on this leftover piece. Whoops, looking at the wrong thing. Cosine x dx. So du is e to the x dx, and v is going to be the sine of x. So our integral is this negative e to the x cosine x plus uv e to the x sine x minus the integral of v du. And we went right back to where we started. Okay, well, what we can do is we can solve for the integral. Okay, now the first time I saw this done, I thought this was cheating. I'm thinking, you're not allowed to do that. You can't say that two integrals of e to the x sine x dx equals e to the x sine x minus e to the x cosine x. That's a Bobby thing. Put it in the middle so it's less of a chance I'll lose it. Plus a constant c. So if I divide everything by 2, we end up with e to the x sine x dx equals minus 1/2 e to the x cosine x plus a half of a constant c, which is just c. All right, so sometimes we have to employ this kind of stuff. All right. Okay, now just random ass problem here. I'm going to give you guys like a minute and a half to try this one out on your own before I jump in. This is going to perhaps involve a couple different steps. Right. Okay. So what did we do here? Let's see. Let's let t equal the square root of x. So that dt is going to be 1 over 2 square roots of x dx, which is 1 over 2t dx. So this means that dx is equal to 2t dt. Okay. So now let's plug it all in. We get the integral of e to the square root of x dx is equal to the integral of 2t and then e to the square root of x, which is e to the t dt. And so that's going to be 2 times the integral of t e to the t, which is t e to the t minus e to the t plus a constant c. Start with x and end with x. So we'll shove that back in what t was equal to. And there we have it. Okay. Any questions on that one?
I had a general question.
Okay.
Could this method of parts be used for any integral or just for ones that are products?
Just products. I mean, you might have a denominator, but you have to treat it as a fraction. So let me find one in here that has that. So let's see here. Okay, here we go. So the integral of the natural log of x over x squared dx. Okay, now here's, we can't use u equaling x squared and dv equaling natural log of x dx, or u equaling natural log of x and dv equaling x squared dx. Okay, we cannot do that. Can't. No. Forbidden. Wrong. When I was in grad school during my second year, I was this one quarter TAing for this visiting professor from some place back east. Name was Montel. Never forget that guy. Anyways, this guy thought that he had cooked up a nifty shortcut for integration by parts. And then he put a problem on the test and everybody kept getting the wrong answer according to him. And I'm like, we're sitting, and it was a small class too. It wasn't one of these massive jumbo classes. There was some reason he had a small lecture math 2B class where there was only like 40 students or something. Anyways, we're in the office with him and he's like, when are they getting this all wrong? And I kind of, I knew he'd been doing things wrong. And in the quiz section, I was fixing everybody's problems. So they all were getting, for the most part, the correct answer because I showed them not to use his method. And then that's when I pointed it out to him. I'm like, your method doesn't work. You can't let the denominator be something. So the only choices that we have here would be to identify the problem like this as the product of 1 over x squared times natural log of x. Or if you don't like looking at it from that point of view, write it like this. Okay. But the point is now we've got some choices here to make on the products. Okay, so because I don't want to have to integrate the log of the log of x if I don't have to, I'll use it in my u. And dv is going to be x to the negative 2 dx. So then du is going to be 1 over x dx, and v is going to be x to the negative 1 over negative 1, which is negative 1 over x. So our integral is going to be uv negative 1 over x natural log of x minus the integral of v du. Okay, so 1 over x natural log of 1 over x. Why did I do that? Why did I take this negative 1 and move it up here as the exponent? Because I know I will lose it. Okay, that's not a rule. You don't have to do that. It's just, I'm like that. I lose negatives. You saw me lose 1 on day 1. All right, so polish this guy off. And then that's going to be x to the negative 1 over negative 1. Okay. I think that about every third problem that you guys do, and the good old days are over, unless there's some massive change in OCC policy, our first test is going to be in room 162. It's going to be on Canvas, but you're going to have to show up, and it's going to be a part 1 and a part 2, and it's going to be weird. But anyways, the days of you guys all, doing it all together. I'm sure you somehow will figure out a way to cheat, but because everybody always does. But what's been happening is that nobody has been doing any practicing. Well, I wouldn't say nobody, but most people haven't been doing homework. They've just been taking the test because they know they can do them all in groups, in Zoom and stuff. I sat right next to my son, before he changed his major. He was taking basically Math 280 at USC. And him and his classmates, they're working on all these problems. I'd help them, with things if we needed it. But what the professor did is he realized everybody was doing group projects. So these problems were ridiculously hard. And I thought, man, he's missing the point here. They're not learning anything. He's just got to put it on them to do homework. But anyway.
I have a question.
Yeah.
So how did the x in the ln of x turn into 1 over x?
Because I have negative 1 over x natural log of x. That's equal to 1 over x times a negative 1 times the natural log of x. So you can move that up into the exponent like that.
Okay.
And the reason I did that
Could you keep it as negative 1 over x times ln of x?
Sure.
Okay.
The only reason I do that, like I said, is because I have a habit of, losing these things.
Okay. Thank you.
Okay. Let's see here. There's one for you guys to try. Go ahead and spend 60 seconds on this before I jump in and solve. Okay. Throw some stuff in the trash can while you guys are integrating by parts on that problem. All right, not much choice here, right? U equals sine inverse of x, dv equals dx. So du is going to be this thing, and v is now going to be x. So our integral of sine inverse of x is uv minus the integral of v du. And show you how my high school teacher Plackmeyer would do this problem. He knows he's
Professor.
going to let u be 1 minus x squared. So Plackmeyer would put a -2 right here and a 1 over -2 right there. Somebody have a question? X sine inverse of x plus 1/2 the integral of u to the -1/2 du. So that's x sine inverse of x plus 1/2 u to the 1/2 divided by 1/2 plus a constant c. Start with x, end with x. X sine inverse of x plus the u which is there to the 1/2. Maybe I shouldn't have used u again in the substitution. And that's what we got for that guy.
How did you get the 1 minus x squared?
That's the derivative of sine inverse of x.
Oh, okay, thank you.
And so why did you do that step where you put the 1 over -2 and the -2 in there?
So that's what my high school calculus teacher used to do. So what we had was this integral x dx over the square root of 1 minus x squared. You know, if we were to let w be 1 minus x squared, then dw is -2x dx. So x dx is negative dw over 2. So you would have to go -1/2, and then it's going to be w to the 1/2 power dw. And so here's the thing. Just that Bill Plackmeyer, who was my high school calculus teacher, he would do things like that. All right. A couple more of these before we move on into other things. How about this guy here? And I'm, of course, trying to bait you into doing something, right? You can't let, if you're going to try to do parts, you can't do it with one of the pieces being natural log. Doesn't work like that. All right, so I'll give you a minute. So this looks like there's not much hope at all unless we just kind of think, all right. The only thing we really can do here is let U be this guy, right? And so dV would then have to be just the dx. Okay, now the du, this is going to be negative sine of the natural log of x times the derivative of the natural log of x, which is 1 over x dx. So v would then just be x. So it's equal to uv x cosine of the natural log of x minus the integral. So there's going to be a minus minus. Maybe I should put minus minus just so we remember that's what happened. And then the x's are going to cancel and we're going to get the sine of this guy. Okay, so I'm suspecting that this is a solve for it guy. So again, if we do parts on this part, sine of log x, and then dv just being dx, du is going to be the cosine of the log of x times the derivative of the log, and the v is just going to be the x. So our integral of the cosine of the natural log of x dx is equal to x cosine natural log x plus uv x sine of natural log x minus the integral of v du, which is going to be this guy. And then there'll be a plus the constancy. So bring it to the other side, two of them equals x cosine log x plus x times the sine natural log x. And so the end of the story, final answer is 1/2 x, and maybe I can cosine of the log of x plus the sine of the log of x plus some constancy. Okay, now I don't have
Could
to tell
you
what
could you
numbers
scroll
to
up for just a second?
I don't have to tell you what numbers to do. Do all the integrals. You see the integral sign, do it.
Thank you.
Okay. All right, well, good time to take a break. Week from Tuesday, I always try to take the break at like 11:45, maybe between 11:15 and 11. So take 10 minutes here. I'll pretend like I'm walking over to check my mailbox. You guys all
Mine's scrolling down
scrolling this way.
towards the bottom of the notes.
That is the bottom.